Greetings pre-cal students. In the last video I showed you how to calculate the dot product of two vectors in two different ways. In this video I'm going to show you the relationship between those. So in the last video we learned that the dot product of two vectors, if you had those vectors in component form, like you see here, is really easy to do. It's the x times x, so the two x values multiplied together, the two y values multiplied together, then you add those quantities up. There is another form for calculating the dot product of two vectors, which looks a little more intimidating. It's the magnitude of the first vector times the magnitude of the second vector times the cosine of the angle that's between them. So obviously, in the setup of this problem, we don't know anything about the angle between the two vectors, and in fact that's what we're asked to find. We have to find the measure of the angle between the two vectors. Now, long story short, and this isn't 100% true, but it's good enough. This first form of the dot product of two vectors, this is the way mathematically is really convenient to think about the dot product. It's very simple. It's easy to do calculations this way. However, when you actually want to do anything with that calculation, when you actually want to understand it, so for lack of a better word, when you're interested in the science of vectors, thinking about the dot product in this second form is much more interesting. So let's see if we can tackle this problem by examining the two forms of the dot product. So the math way of calculating the dot product we're set up in this problem to do sort of from the start. It's very simple. We just say that vector u dot vector v is 5 times negative 7 plus negative 3 times 1. So that's negative 35 minus 3, which is negative 38. So that's the dot product. And when you're new to the dot product, you look at this number and you say, well, what in the world does this number mean? I have no idea. How is that related to these two vectors? It's not until you compare that and contrast it with the second definition of the dot product that you can start to get a sense for what it means. So with the second form of the dot product, you need the magnitude of the two vectors that's involved. So let's go ahead and calculate those. So we have the magnitude of vector u, which we've had the formula for magnitude for a while. It's basically the Pythagorean theorem. We have the square root of 5 squared plus negative 3 squared. So that's the square root of 25 plus 9. That's the square root of 34. And then for vector v, the magnitude of v is, do the same thing, negative 7 squared plus 1 squared. That's the square root of 50. Now I do like to simplify my radicals most of the time, so 50 is 25 times 2, and the square root of 25 is 5. So the magnitude of vector v is 5 times the square root of 2. Now the sticking point when you're dealing with vectors is the last part of this formula, the cosine of the angle that's between the two vectors. So this is what we have to find. Now in order to do that, we're just going to look at, this is an equation. It says u dot v. That's the dot product of the two vectors. Well, I know what that is. It's negative 38. The dot product of the two vectors is equal to the magnitude times the magnitude. Well, I know what the two magnitudes are. We have the square root of 34, and then 5 times the square root of 2. I don't know the cosine of the angle between the two vectors, because I don't know the angle between the two vectors at all. However, this is an equation. You can solve that equation. So let's do that. First, just do some arithmetic. 34 times 2 is 68. And I'm going to break one of my own rules. Normally I would simplify this radical, but I don't feel like it, and I know the next step in this problem we're going to go to a calculator anyway. So let's get cosine theta by itself. So I just have to divide by have to divide by 5 square root 68 on both sides. So we have cosine of theta is negative 38 over 5 square root 68. At this point, we're going to go to our handy-dandy calculators, and we'll finish solving the equation there. Let me erase some of this work that we don't need anymore, so you can see the calculator screen. All right, we have the cosine of theta is this ugly number. Well, all we have to do to solve that equation is take cosine inverse on both sides, just like we did back in our trigonometric equation days. So take cosine inverse, and we have cosine inverse of negative 38 over 5 square root 68. Press enter, and we should have something really ugly with our nice calculators. So press Control Enter, and you'll have the angle between the two vectors. So here the angle between those two vectors is 157.2 degrees. So that's how you find that. And that will really take care of your main assignment for the week. Let me just point one thing out. This looks very much like your assignment. Once you get to the last set of problems, it looks like you're doing something different. It's really not. Two vectors are switch to the pen. Two vectors are parallel to each other if the angle between them is 0. So do what we just did in the example. If the angle between the two vectors is 0, then you know that they're parallel vectors. Now, this looks like a new word. I promise you it's not. Orthogonal in math is basically a synonym for the word perpendicular. There's some slight differences, but not really. So if you calculate the angle between two vectors and you get 90 degrees, it means that they are orthogonal vectors. And if you get anything else, the answer is neither. So for this last set of questions, just calculate the angle between the two vectors and then think about if the angle is something special or not. Anyway, that'll take care of your main assignment for the week between this video and the last one. As always, just email me if you need anything else. See you next time.